Hi class, this is Coach Riza. For today, we're going to talk about the intermolecular forces of attraction. Last time we had talked about the difference of intermolecular forces and the intramolecular forces. When we say intramolecular forces, these are the forces that holds atoms together within a molecule. So it is also known as the bonds. While the intermolecular forces are the forces that exist between molecules. Again, it is between the molecules. As we can see, class, we have here molecules of hydrochloric acid. So as you can see, hydrochloric acid is a polar molecule because of the presence of the partial charges. Why is this have a partial charge? It's because, again, they have a different electronegativity value. One is higher and the other is lower, causing this charge and a dipole moment. That is why this is a polar molecule and they have a polar bond, and that bond is also called the intramolecular force of attraction. Now, in between these molecules, there is this one force of attraction, which is known as the intermolecular force of attraction. So in this video, we're going to find out how does intermolecular forces of attractions are formed. So how does it happen? So let's find out. So intermolecular forces, these forces holds the molecules together, which can be attractive or repulsive. It's like magnet. Two molecules are either attracted or repulsive to each other. Okay? And these attractive forces are much weaker than the bonding forces. If we look at the bonds, as we can see, bonds are made up of sharing or transferring of electrons. That's why a bond is formed. While the intermolecular forces, it is due to the force of attraction. Okay, so there will be an attractive and repulsive process between two molecules. So let's find out how this intermolecular forces happens. We also have an inter-ionic force, wherein inter-ionic forces are forces that hold ions together. This one is not under intermolecular. This is another type of force that is focused more on the ions. So it's between ion to another ion. So that's why it's called the inter-ionic forces. Intermolecular forces determines the physical properties of molecules like their boiling point, melting point, density, enthalpies of fusion, and vaporization. So these intermolecular forces, as I have said, are accountable for the properties of substance. Okay? So moreover, intermolecular forces also explain why substances exist as solids, liquids, or gases at room temperature. So different types of interaction on our intermolecular and inter-ionic force of attraction. So we have here dispersion, dipole-dipole, ion-dipole, ion-ion, and hydrogen bond. Ion-ion is part of the inter-ionic forces. The rest is part of the intermolecular force. Now, the interacting particles for dispersion. All molecules, especially nonpolar molecules. Dipole-dipole, polar molecules. Ion-dipole, ions and a polar molecule. Ion-ion, of course, it's between ions, cations and anions. Hydrogen bond, it's called hydrogen bond, but it's not literally a bond. It is called this way, hydrogen bond, because of the interacting particles. It is because hydrogen atom is bonded by either fluorine, oxygen, or nitrogen. So again, hydrogen bond is an intermolecular force of attraction. So as I have said, there are 4 types of intermolecular forces. First is the dipole-dipole, second ion-dipole, third dispersion forces, and fourth is the hydrogen bond. Now these three types, the first 3 types, are known as the van der Waals forces. It is named after a scientist which is van der Waals. On the other hand, hydrogen bond is a special type of dipole-dipole interaction. So we will later on find out about hydrogen bond. Just to give you an idea, who is van der Waals? Here it is. He is Johannes Diderik van der Waals, was born on November 23, 1837 in Leiden, the Netherlands. In his thesis, van der Waals noted the non-ideality of real gases and attributed it to the existence of intermolecular interactions. So basically, he's the one who discovered this intermolecular interactions, and it was named after him the first three intermolecular forces of attraction. Now let's move on to the first type of intermolecular force of attraction. It is dipole-dipole forces. So dipole-dipole forces are attractive forces existing between polar molecules. So when we say it's a polar molecule, it is the molecules that exhibits dipole moment. Okay, so such as HCl. So as we can see here in the illustration, we have here a polar molecule interacting with another polar molecule. So what happens here is that they're forming the dipole-dipole forces because of the interaction between the two molecules. The partial negative part of our HCl here is attracted to the partial positive part of another molecule, which is another HCl on this side. So that's how intermolecular forces are formed. It is because of the partial charges or the signs. They attract each other because of the opposite signs or opposite charges. So dipole-dipole forces, that's why it's called dipole-dipole. Again, take note class, dipole can only be present in polar bonds. Okay, so polar molecules, dipole-dipole. So it's between a polar and a polar molecule, just like in this example. So dipole-dipole interactions, these forces occur when the partially positive charge part of the molecule interact with the partially negative charge part of the neighboring molecule. So this opposite charges attracts each other. Because there is an equal sharing of electron between H and Cl atoms, there is the presence of partial positive and partial negative poles. And thus, we refer that as a dipole. The charge regions are what we call the dipole. So meaning to say, this is a polar molecule, or the molecule has polar bonds and it's a polar molecule. So again, dipole-dipole forces. So because of the poles, opposite charges attracts, as we can see here in the illustration, forming our intermolecular force, which is the dipole-dipole force of attraction. So this force is weaker than ionic and hydrogen bond. So see, ionic here is the ionic bonding. So ionic bonding is stronger because it's a bond. So bonding for ionic is transferring of electrons. Well, this one, dipole-dipole force, is a force of attraction formed because of the charges or the partial charges being attracted to each other. So that is our dipole-dipole forces. So this is the illustration how our molecules interact with each other. All the molecules here are polar and they are interacting with each other. So both have attractive and repulsive. We have a part where they will attract to each other, and both attractive and repulsive dipole-dipole interactions occur in a liquid sample with many molecules like this. As you can see here, they have already interacted with each other. They have already attracted to each other because again, as we can see, opposite charges attracts. So again, opposite charge or partial charges attract. So there is an attraction between the molecules. And if it's on the same sign or same charge, there will be repulsion or they will repel each other. So next is ion dipole forces. So it exists in the attraction between charged particle called ion which can be positively charged cation or a negatively charged anion, and a polar molecule. So again, class, it's between an ion and a polar molecule. That is why it's called ion-dipole forces. So this exhibited in hydration, or the interaction of water molecules with the cations and anions of ionic compounds dissolved in water. So let's have an example. When sodium chloride is dissolved in water, sodium chloride will dissociate into sodium cations and chlorine anions. Because water is a polar molecule and has a partial negative and partial positive poles, the sodium ion will form an ion-dipole interaction with the partial negative part of the water molecule, while the chlorine ion will form an ion-dipole interaction with the partial positive part of the water molecule. As we have seen in this illustration, we can see that an ion, a negative charge, will be attracted to a positive or a partial positive side of our polar molecule. Same goes with cation, a positively charged ion will be attracted to the negative or partial negative part of a polar molecule. As I have said a while ago, sodium chloride, also known as salt, when dissolved in water, will dissociate. So meaning, maghihiwalay si sodium at si chlorine, forming the sodium ion and the chlorine ion. So these ions will be attracted to the water molecules. Like this one, as we have seen here, chlorine is negatively charged. That's why it's attracted to the partial positive side of the water molecule. And the sodium ion is positively charged. That's why it's attracted to the negative or partial negative part of our water molecule. Okay, so that is our ion-dipole interaction. Ion-dipole forces are formed between the molecules. Next is dispersion forces or London forces. These are the weakest attractive force that are formed due to the temporary dipoles induced in nonpolar molecules. So if you could still remember, class, nonpolar doesn't have dipoles. But for this case, because of the interaction between the molecules, the nonpolar can have temporary dipoles. And this force is called the induced dipole attraction. So let's find out what will happen if a nonpolar interacted with another nonpolar. So as we all know, the bond between these two is a nonpolar covalent bond. And as we can see here in our illustration, this represents the intermolecular force. And for our case, for nonpolar, it is the London dispersion forces. Now let's find out how this nonpolar will have a temporary dipole. So we have here an illustration of what will happen to our nonpolar. Let's say we have a nonpolar, and as we all know, it has no dipole. It means it doesn't have any partial sign. But when it interacts with another nonpolar, what will happen is that there will be a distortion on the electrons within our molecule. Because they are attracted to each other, the electrons within are adjusting as well. So the other side will have a partial positive and the other side will have a partial negative part. Same goes to the other nonpolar molecule interacting with the other nonpolar molecule. There will be a distortion within wherein the electrons are moving to the other side. So the other one is partial positive and the other side is partial negative. And of course, because opposite attracts, they will form the force of attraction, the intermolecular forces, which is we call the dispersion forces or London forces. So it means our nonpolar was induced. So it has a temporary dipole. So it forms a temporary dipole because it was attracted by another molecule, a nonpolar molecule. This one is the same Like what I've explained a while ago, nonpolars, two nonpolar atoms, when they interact, there will be a momentary attraction and repulsion, wherein the electrons within are distorted, forming the partial signs, and later on they will be attracted to each other and will form the intermolecular force, which is the London dispersion force. So London dispersion forces has types. So first we have the induced dipole force. Molecules that have induced dipoles may also induce neighboring molecules to have dipole moments. So a large network of induced dipole interactions may exist. So it means there is a presence of induced dipole. When we say induced dipole, it is a nonpolar that has a temporary dipole. So it means the other nonpolars doesn't have any partial charges yet. So with the presence of a induced dipole, it will induce the other nonpolar molecules near it. Okay? So it's like when someone is sick and then pumunta siya sa isang lugar na maraming tao, of course, the possibility na makahawa is high. So, again, this is just an example wherein may induce dipole na. Okay, so it means that it has a partial charge. The rest doesn't have yet any partial charges. With this present at tumabi na siya sa other nonpolars, this will create a chain of reaction. So this one will induce the other nonpolar molecule, and then later on it will create a network of induced dipole interactions. So dispersion forces or London forces are not only exclusive for nonpolar to nonpolar. It can be ion to nonpolar or polar to nonpolar. So because of the presence of an ion or a polar or a nonpolar interacted to another nonpolar, there will be a distortion within our nonpolar. So this distortion will result in the temporary dipoles in the nonpolar molecule, which is called the induced dipole. So when we say induced dipole, it is the separation of the charges in a nonpolar molecule due to the nearness of an ion or a polar molecule or a nonpolar molecule. So we have two more London dispersion forces. First is the ion-induced dipole interaction. This is due to the interaction between an ion and a nonpolar molecule. So the interaction is called ion-induced dipole interaction. So what happens here is that we have a nonpolar, and then there's a ion went near a nonpolar. Because of that, because of the presence of an ion near a nonpolar, the electrons will shift on the side. As you can see, this dot there represents our electrons. And because there is a presence of a positive ion here, this one, the nonpolar, will adjust, will form the partial charges. For this side, there is a partial negative because opposite attracts, and this side is partial positive, creating the ion-induced dipole interaction or the force, intermolecular forces of attraction. Another one is the dipole-induced dipole interaction. So it is due to the interaction between polar and a nonpolar molecule. That is why it's called induced dipole interaction. So we have here a polar molecule, and as we all know, they have partial charges. Once it goes near or approaches a nonpolar molecule, the nonpolar molecule will be attracted to this polar molecule. So since the other end is positive, the nonpolar will adjust its electrons. It will shift near the positive, so it will have a partial negative sign here and a partial positive here. So it is induced dipole because again it has a temporary dipole. So that is the dipole-induced dipole interaction, an interaction between a polar and a nonpolar molecule. Last but not the least is hydrogen bond. Again, take note class, it's not literally a bond, but rather it is named after the elements that is being bonded to each other. So it is a special kind of dipole-dipole interaction that occurs specifically between hydrogen atom bonded to either oxygen, nitrogen, or fluorine atom. So these three elements are highly electronegative atoms: fluorine, oxygen, and nitrogen. So we have here an example illustration wherein we have water molecule. So as we all know, water is polar, and again they have partial charges. And of course, the opposite sides of the polar molecules interacting with each other are attracted to each other, so forming the hydrogen bonding, the intermolecular forces. So hydrogen bonding is relatively strong force of attraction between molecules, and considerable energy is required to break hydrogen bonds. So this explains the exceptionally high boiling points and melting points of compounds like water and hydrogen fluoride. Hydrogen bonding plays an important role in biology. For example, hydrogen bonds are responsible for holding nucleotide bases together in the DNA and RNA. So that's how strong our hydrogen bond is. And take note, class, it's not literally a bond, but rather it's an intermolecular force of attraction. So the relative strength of intermolecular forces of attractions, as we can see here, dipole-dipole attraction. So strong ang kanyang strength. Hydrogen bonding, mas stronger kaysa sa dipole-dipole. London dispersion attraction is weakest because it only has a temporary or induced dipole. So, pag nawala na yung ka-interacting na molecule niya, the non-polar molecules will go back to its normal state. Okay, mawawala yung temporary dipole because again, it's just temporary. Okay, so that is why it's the weakest among all the intermolecular forces of attraction. For your activity, you're going to use this schematic diagram. So what you're going to do in your activity is that you're going to identify what type of intermolecular forces are present in the molecules. Okay, so on our molecules. So let's see how are we going to use the schematic diagram. So let's say we have iodine bonded to another iodine. Iodine is a nonmetal. So nonmetal to nonmetal bonded to each other. As we all know, this is a nonpolar molecule. So iodine bonded to another iodine is a nonpolar. So first question, are ions involved? No. Are polar molecules involved? No. That is why it's under the London forces. Okay? So another example, we have water. As we all know, water is non-metal to non-metal. And as we all know, water is a polar molecule. So are ions involved? No, because it's non-metal to non-metal. Are polar molecules involved? Yes. Are hydrogen atoms bonded to N, O, or F atoms? Yes. So this is a hydrogen bonding. Okay? So last example is, let's say we have sodium chloride. So sodium chloride, it's a bond between a metal and a non-metal. So are ions involved? Yes. So metal to non-metal, it's ionic bonding, meaning to say ions are formed. So yes. Are polar molecules and ions both present? No. Only ions are present. So that is why it's ionic bonding. So you can see the schematic diagram will help us to identify our types of intermolecular forces in our molecules or between our molecules. So that will be your activity for this lesson.